One of the biggest unsolved problems in modern AI is something called catastrophic forgetting. It is the reason current models can't actually learn continuously the way humans do. Every time you train them on something new, they override what they already knew, and this bottleneck is holding back artificial general intelligence. But now Google just released a research paper that might finally change that. They call it nested learning. And if this works, it could fix AI's biggest problem. But before we go any deeper, let me quickly explain what catastrophic forgetting actually is, so it will be clear for you to understand the research paper. When we talk about AI today, we often treat it like a super intelligent machine, but that's not actually true. Modern AI systems have one massive defect. They have a risk of forgetting almost everything the moment you teach them something new. Catastrophic forgetting happens because neural networks store all their knowledge in ways. To understand better, first we need to understand what the way is. Think of a way as a tiny adjustable setting inside the machine. A neural network has millions of these ways, which are just numbers that can go up or down. These numbers decide how strongly an input will influence the output. So when you use ChatGPT or any other AI model, every single word it generates is chosen based on the values of its ways. Those tiny numbers determines what model thinks you mean, what it should pay attention to, and what it should say next. At the very beginning, these ways are completely random. During training and fine-tuning, engineers adjust those ways millions of times. So the model gradually learns to produce accurate, helpful, and human-like answers. And keep in mind, that's where the problem starts actually. When you train a model, it doesn't store facts in a database. It stores patterns inside millions, sometimes billions of tiny numerical values called weights, as I explained a minute before. Each weight represents a tiny piece of what the model knows. So training a model is basically just changing those weights over and over until it behaves correctly. But here is the problem start. When you train a model on a new task, let's call it task B, it adjusts its ways to better at B. But those same ways can change accidentally and break the pattern it learned for task A, which simply means the model forgets what it learned before. If it was happening to us, it would be like, imagine you study math for years and then someone teach you Spanish, or you would like to study Spanish, and while you are learning Spanish, suddenly you forget all the math you ever learned. That is called catastrophic forgetting. It is one of the biggest reasons AI can't really learn over time the way humans do. Humans have layers of memory. We keep short-term ideas in our immediately awareness. We store long-term memories for years, and we can learn new skills without deleting the old ones. For sure, we don't forget things, right? AI can't do that, unfortunately. And when you fine-tune a model, you override huge part of what it already knows. This is exactly why experts like Karpati call catastrophic forgetting a major bottleneck to AGI. Because no matter how big these models get, they still can't continuously learn like humans do. And this is the problem Google is trying to solve. This is the most important part because you will understand how magical best engineering your brain is. Let's jump right in here. This part of the paper shows the relation of nested learning to the human brain. It simply says that brain's ability to rewire itself. Your brain can strengthen old connections, weaken others, or even create new ones when you learn something new. And the reason this works is because your brain has a flexible structure that can be reused in many ways. This is more about how our brain works at different time scales. Some neurons fire quickly for fast reactions, while others update slowly for long-term learning. This multi-speed system is what keeps our learning stable. When you touch a hot pan, your brain reacts instantly. That fast reaction is your neurons firing at high speed. In nested learning, the model is split into many small learning units, and each one updates differently. It is similar to how the human brain has different regions that learn and adapt at different speeds. And each part of the model updates at its own rhythm, so some layers update fast and pick up new information quickly. Others update slowly and protect long-term knowledge. Because everything isn't updating at the same time, new learning doesn't shake up the whole model. That's how NL avoids catastrophic forgetting. Now you can ask, like, what is the difference from normal machine learning? In regular models, there is basically one global clock, one learning rate, and one update step. So when new data causes a strong gradient, every weight gets changed, even the important one. The model cannot say this way is important, leave it alone, or this way isn't important, do whatever you want. Always get shaken the same. It is like relearning your entire personality every time you learn something, you learn a single new fact. That's why normal AI forgets old knowledge so easily. Nested learning fixes this by giving each part of the model its own learning speed. Fast layers learn fast, slow layers stay stable. So new updates don't disturb long-term memory. They use this nested learning principle in design Hope. Normal AI models stop learning once training is done. But Hope is different. It can actually modify its own memory while it is running. Now, this doesn't mean that Hope can write its own code. It is kind of self-modifying model. What it can do is reorganize its own memory. It can adjust how its internal loops store information and how fast each part of the network learns. So it is not reprogramming itself, but it is reorganizing how it learns. So in this paper, they also shared the results. As you can see here, on the left side, you see that perplexity of model. Hope is the lowest and it is the best between other models. And when you see on the right side, for the task accuracy, Hope again is the best. The conclusion is the nested learning paradigm represents a step forward in our understanding of deep learning by treating architecture and optimizing as a single coherent system of nested optimization problems. We unlock a new dimension for design, stacking multiple levels. The resulting models like the Hope architecture show that a principled approach to unifying these elements can lead to more expressive, capable, and efficient learning algorithm. We believe the nested learning paradigm offers a robust foundation for closing the gap between the limited forgetting nature of current LLMs.